Today we're going to try to explain the three main types of intermolecular forces. First thing to understand is, what does intermolecular force mean? This means that we're talking about the forces that exist between two distinct molecules. Okay, so for example, we can talk about how one water molecule interacts with another. This is intermolecular. Okay, another term you might hear, which is something we are not talking about today, is intramolecular. Intramolecular refers to the interactions between atoms in the same molecule. Today, we're going to be talking about the atoms in different molecules. Alright, we're going to be talking about these intermolecular forces in terms of increasing strength, which means we're going to start at the weakest, but probably the most complicated one, called London dispersion forces. London dispersion forces basically just refer to the fact that the electron shell around the atom can move. It can be warped. It can be changed. Alright, so let's think about it. If I have two helium atoms that are next to each other, we can think about what's going to happen as they get closer and closer. First thing that's going to happen is you're going to notice that both of them have electrons, and those electrons are going to repel each other. So these electrons are going to push away from each other, and so are these protons in the nucleus. They're going to push away from each other because they repel. But these protons and these electrons are going to attract, and these protons and these electrons are going to attract. So what happens as these get closer and closer is that the charges, positive and negative, are going to cause these atoms to warp. They're going to start to look different. They're going to probably start to look something like this. Okay. What happens here is we have the same atoms. They've just gotten close to each other. The positive charge in the nucleus, the negative charge in the electrons are attracting. They're pulling each other in closer. And as they do that, this is going to push away this other nucleus, and these electrons are going to push away these other electrons. The ability to warp like this is called polarizable. The more electrons you have, the more polarizable you are, and the stronger your London dispersion. Right? If I can fit more electrons on this side, then this side is going to be more and more negative. All right, it's going to build up a negative charge, which is shown with this symbol right here, which means partial negative. And over here, we're going to have a partial positive charge, and those are going to interact. Okay, so London dispersion forces refer to this, which is called an induced dipole. We force the creation of partial positive and partial negative sides by bringing these atoms close together. Next, we have dipole-dipole interactions. Dipole-dipole interactions are the interactions between the partial positive and partial negative on permanently charged atoms. Right? So for an example, or a permanent dipole. For example, if I have this molecule and water, well, bromine is going to be partially negative here because it's a highly electronegative element. Carbon is going to be partially positive. On the other side over here for water, oxygen is partially negative, hydrogen is partially positive, and the attraction here between this partial positive hydrogen in water and this partial negative bromine in this molecule, that is a dipole-dipole interaction. And this is much stronger than London dispersion because this bromine is permanently partially negative, not just because it's close to something else. The last type of intermolecular force is hydrogen bonding. Hydrogen bonding, though, you really shouldn't think of it as its own type of intermolecular force. It's really just a very special kind of dipole-dipole. And hydrogen bonding refers only to the interactions between OH bonds, NH bonds, or FH bonds in separate molecules. So, if I had a water molecule next to a hydrogen fluoride molecule, fluorine is partially negative, so is oxygen. H's are going to be partially positive here. And the interaction between a partial positive H that is bonded to an F, an N, or an O, and a partially negative O, N, or F bonded to an H, that is called a hydrogen bond. It is not these bonds, the O to the H or the N to the H. Those are single covalent bonds. A hydrogen bond, remember, is an intermolecular force. It is an attraction that exists between molecules. For another example, if I had a sample of NH3s, N is partially negative, H is partially positive, and if I have another NH3 over here, the interaction between the partially negative N and the partially positive H would be a hydrogen bond. Tune into the next video to see why these intermolecular forces matter.